Chapter 2, Section 5 is about algebraic proofs. By the end of this lesson, you should be able to use the properties of equality to complete algebraic proofs and identify properties of equality and congruence. So proving is something we're going to do for the rest of this geometry class. We got to start out small with this section, but then we'll eventually prove almost everything we do. So a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. If you've ever simplified an expression or solved an equation in algebra, then you've done a proof. We used logic, definitions, properties to show that we can get like x equals 3. But now we're going to justify why. And today we're going to start off with algebraic stuff because it's something we're comfortable with, where geometry, we haven't really learned enough geometry to prove anything yet. So deductive reasoning, think back to what we did earlier this chapter. This was in your algebra textbook. Deductive reasoning is the process of reasoning logically from given facts to a conclusion, so using facts and definitions. So back in the day, you took a nice little expression like this, and we combined like terms, and then ended up simplifying it to negative 3b plus 9. Now there's reasons behind why we can do what we do. So instead of just writing b, we could write it as 1b, and that's the identity property of multiplication. We can switch around the order so that the b's go together. That's the commutative property of addition. We can use the distributive property and combine our like terms there. And then we can just add negative 4 and 1 to get negative 3b plus 9. So you do all these steps without thinking twice about why. Today's job, we're going to give reasons for everyone. So these are properties that you need to know. The addition property of equality. If a equals b, then a plus c equals b plus c. So this is going to come in handy when we end up solving things, like if I subtract c from both sides and it ends up crossing off. The reason that this works is because of this property. You have the subtraction property of equality, the multiplication property of equality, and the division property of equality. All of these kind of run together. And then we have the reflexive property of equality that says each thing on the side of the equal sign are exactly the same. We have the symmetric property of equality, which says that you can rearrange things. So if you end up with something like 3 equals x, you could rewrite that as x equals 3, and it means the same. The transitive property is kind of like the law of syllogism. If a equals b and b equals c, then we can skip the b part and just jump to a has to equal c. And then the substitution property of equality. If a equals b, then b can be substituted for a in any expression. So like if I tell you x equals 3, and then I tell you that 8x equals 24, you could plug that 3 in. You can substitute it. So let's solve this equation and then justify why we did each step. I'm going to go through and solve it just like I would in an algebra class, and then we'll go back and prove why each thing works. So the first thing we want to do is add 8 to both sides. So this crosses off. I get 4m is now equal to negative 4. And then divide both sides by 4. That simplifies to just m equals negative 1. So now let's think about our reasons. This right here is just our given equation. So that's what they give us. The reason that we can add 8 to both sides and still make the equal sign true is the addition property of equality. Remember back here, addition property of equality says that if I have addition on both sides, that it's exactly the same equation, that a just equals b. And then I simplified to get this step. And then I divided everything by 4. So this right here is the division property of equality. that says I can do this. And then again, I had simplify. So hopefully solving the actual equation was nothing new, but giving a reason why we can do everything is the only new part of 2.5. So here's another example. What is the temperature in degrees Fahrenheit when it is 15 degrees Celsius out? Solve this equation. The Fahrenheit temperature equals 9/5 the Celsius temperature plus 32. We need to justify each step. So the first thing we're going to do is plug in what we know. We know the Celsius temperature is 15 degrees. So let's plug that in. 9/5 times 15 plus 32. If we multiply those two together, we're going to end up with 5 goes into 15 3 times. So you get 9 times 3, which is 27, plus 32. And then add 27 and 32 together, and you get 59. So now let's go back and justify why we did each step. So the first thing right here, this was our given equation. And then the next thing we did was substitution. That was the very last thing that we had back here, substitution property of equality. We can plug something in if we know what it equals. And then what I did here was just some multiplication. And then here I just did some addition. We can also write these as simplification. So we could write that we just simplified. So proof in geometry. So like algebra, geometry also uses numbers, variables, and operations. For example, segment lengths and angle measures are numbers. So you can use these properties to write algebraic proofs with geometry stuff. So think back to chapter 1. We learned the segment addition principle, which said the distance from N all the way to O is broken up into NM and MO. So we can make an equation for this. 4x minus 4, this top part, has to equal 2x plus 3x minus 9. And then the next part, we do some simplification, we get an answer out. So we're going to write a nice little justification for every step here. So this right here, the reason we can say that that whole segment is made up of little segments is the segment addition postulate. And then if you notice, the next step, we replaced NO with what NO equals. We replaced NM with what NM equals, and MO with what MO equals. So this is our substitution. And then we did some simplification on this side. We added 2x and 3x together, so we have addition. And take a look at what they did. Suddenly we only have 1x. So they did this and subtracted 4x from both sides. So we can say they used the subtraction property of equality. And then again, without much work, they added 9 to both sides, and that's where they got the 5 from. So we can say that this was the addition property of equality. And then finally, we have our answer, x equals 5. We can also write this as x equals 5, just like we said it, and that would be the reflexive property. So using something that we just learned in geometry, we can still use these same algebraic steps to justify why we're allowed to do what we did. So more properties that you need to know. The reflexive property of congruence, the symmetric property of congruence, and the transitive property of congruence. So remember, all the properties before were of equality. When we're describing the measure of something, we don't use equal, we use congruent. So if figure A is congruent to figure A, like the length from E to F is congruent to the length from E to F. The symmetric property says that we can go backwards, that if angle 2 is symmetric to angle 1 has to be symmetric to angle 2. And then transitive is kind of like the law of syllogism, where you cross off what's in the middle and you can jump conclusions. So identify the property that justifies each statement. Angle QRS is congruent to angle QRS. That right there is the reflexive property. If the measure of angle 1 equals the measure of angle 2, the measure of angle 2 has to equal the measure of angle 1. If you look back here, that's the symmetric property. And it's symmetric of congruence and reflexive of congruence. If the length of AB is congruent to the length of CD, and the length of CD is congruent to the length of EF, then we can draw the conclusion that the length of AB is congruent to the length of EF. That one right there is where we cross off the middle. It's kind of like the law of syllogism. So it would be the transitive property of congruence. And then we have some more measures. 32 degrees equals 32 degrees. Be very careful with this one. It has equal signs there, not congruent symbols. So this is the reflexive property of equality, not of congruence. There is a difference. So we're at the end of this lesson. You should be able to use the properties of equality to complete algebraic proofs and to identify properties of equality and congruence. And we'll do some practice with this stuff tomorrow. Have a good night.